Okay, so looking at another great troubleshooting tool for DNS is Dig. Okay, and we'll display some examples here of how you can use Dig. So first, we can search for a specific record type. So this indicates Dig, and we specify a global listener. In this case, just the Google DNS server to google.com, looking for a specific query type, so MX, right? Reverse DNS lookup is using the dig-x, and you can see basically a pointer file resolving the IP address to a name. We can trace the DNS path, which is really quite useful when troubleshooting, like to the root, like the whole DNS tree. You could do a dig google.com plus trace. We'll take a look at all these examples in the command line here in a second. The adjust answer size is a nice way to display just a short, quick message of the answer, and not the additional section or not the question section. Just a nice, real brief answer to what you requested. We can use IPv4, IPv6. So to specify IPv6, we can use the -6 at our global listener, and this specifies we want the A record for google.com. Okay, so the next one is query all DNS record types, dig google.com any, and some authoritative DNS servers will choose not to respond to any, just to help with specific attacks. But this will display any DNS record types it finds for that specific domain.com, or is authorized to send for that domain. All right, next we'll find out the TTL, or time to live. So with DNS, it's really in seconds of how long that DNS record can stay in cache. So if we wanted to see those values, we can use the dig command. In the answer section, there's going to be the TTL units, and this is the standard units in seconds, which you can see for the A record google.com. We can also specify the local DNS server when we're making the request. We can do this by doing a dig host at our local DNS server to the record that we want to query from. All right, so it may be beneficial if you're using, before you're using or migrating to the F5 as your LDNS, point to it from a client and point to the F5 as your LDNS to see the traffic patterns before you actually switch your clients to use the F5 as your LDNS. It's going to stage the effort. Okay, so now let's jump to the command line and look at a few dig examples. The first thing we want to look at is just the version of dig that we're using on the F5 system. So this is a 14 base system, and it's using dig 9911p1. I've got a client here who is on 9110p2, and for the demonstrations I'm going to use the client, but in all reality the system will use basically the same options for both. I've just got the client set up with more networking connectivity at this point to demonstrate dig, so I'm going to use that for our purposes here. Okay, so let's start by doing a dig to our global listener for google.com, and then we'll specify the MX. Okay, we see the MX records listed here. It's going to use the lowest priority one by default, and go from 20, 30, 40, 50 down here. But the question section indicates what we've asked for, and our answer section indicates what we've received. All right, the global listener in this case was 8888, and the query time was 37 milliseconds. Okay, so a reverse DNS lookup. So if you do like a dig f5.com and you have the A record for f5.com, you could take that dig X and copy and paste the IP address, and that's going to give us that's going to automatically point or append the in-addr.arpa pointer file and give us the association for that IP address to name, so we can see who's authoritative for that specific domain. So in this instance, the P DNS130.f5.com is responding for that PTR request. Okay, and we can also use the trace flag in dig. We do dig google.com plus trace, and we start all the way at the top for the, notice we go from the root servers to the .com servers, and then to who's authoritative for google.com, or who the name servers are for google.com, and then we receive our A record. So it's a nice way to trace DNS. So that's a lot of output. Normally you may not need all that output, and maybe just looking for a simple test or batch script query, you could use dig google.com plus short, and this just gives you the IP address of the answer section. Okay, we can look at all DNS record types from a domain using dig. We use google.com and then any record type. In some cases you may want to also use plus multi-line just to get it in a proper expanded format, where you can notice by the SOH section that is a little clearer and easier to read. But this again will display all the record types for google.com. So you see A records, quad A records, TXT, MX, etc. Okay, so if we were interested in time to live values for DNS records, we'll just do a dig-h, and then you can look at the TTL. If you're wondering how to identify, maybe this is a Windows client, obviously it's a C drive. If you're on a Windows client, you can use dig-h and then do a find for TTL in quotes, and you can just get that information. So grep works on Linux platforms, but dig can be installed on Windows clients and then also used in Unix clients as well as Mac OS. Okay, so TTL, this displays the control of TTL in records. So this is the TTL ID. This is the normal record in seconds that you'll see. This specifies it in minutes or hours, making it easier to digest for humans. So we were doing a dig plus no CMD, no all, plus answer section. And notice this is left to right, so when we're displaying no all, this is basically clears all flags. So clears all flags, but then if we're specifying answer, it's only the answer section. Okay, we're going to indicate TTL units, A record for google.com. Okay, so you could see instead of seconds, it's displaying roughly 5 minutes, and then the A record for google.com. All right, the normal TTL again is in seconds, but if you wanted to see it in minutes or hour format, then you can do the TTL units. Okay, so say we were, notice the dig-h, we see that if we point at, this is the global server, but we can also use host at local server to specify our local DNS. So maybe if we wanted to prep the F5 to be our local DNS server, we could point to that as our local DNS server to resolve queries and maybe test the transparent cache feature before we actually put it in line for our clients. In this case, I'm just going to go to dig host. We'll do the level 2 DNS server as our local DNS server and specify google.com. So by default, it's going to send for that to the LDNS server, and the LDNS server is again going to take that information and get us the answer we're looking for right away. And this is also specified with the RD flag. Okay, and let's look at a couple more examples of dig. So we looked a little bit about the expanded format using the multi-line flag. We can this works well for instances where you're displaying a lot of records and maybe particularly the whole zone. You might want to do the multi-line. And the no all basically clears all the display flags, and then we're specifically looking for the answer section after that. So notice it's to the right of the no all. The no CMD turns off display for the control command line, and then we're doing a normal query for google.com any record. Okay, another use case which is really cool is using dig before or after DNS change. So let's say we're authoritative for both domain.com and domain2.com, and we want to move these zones to the F5 DNS. We could do a dig result before and after that DNS change when we're moving it to the F5 box. So we'll start by creating a file. You can name it whatever you'd like. In this case, we're on a Unix client. We do vi dig.txt. If you're on Windows, you can just create a normal text file and dump these two comments or lines into that file and save it. Okay, this is basically looking for just the answer of domain.com and what type it is, and then the answer for domain2.com and what type it is. And no TTL ID is indicating we don't want to see the TTL, because that might change depending on who owns that domain. Maybe we do want to specify it, and you can leave that out to see what changed. So after we create that, we can run a dig and point it to this file digs.txt to another file called before DNS change, and then we can make our DNS change and then run the same dig after and call it after DNS change. And then if you're on a Unix platform that supports the diff function, you can do a diff before to the after, and then see using the diff feature what records had changed before and after our change. So it's a really nice way to validate that your DNS change was successful, and also if there's any major hiccups with any records that you may have not accounted for. Okay, now let's jump to the command line and look at that dig before and after DNS change. Okay, so we can start out by creating a file. Just name it, we're in the config directory. It's going to be a small file, so that's fine. We can do a vi dig.txt, and I'll just copy some of the lines that we want to specify, and I forgot to do a Control-Shift-D, but you can get your lines how you want them, right? So we're only looking for the answer section with no TTL information for just these 4 domains. Okay, we'll save the file. Okay, and then we can do a dig and point to that file we just created and point that to another file. Okay, all right, so that's the records are populated in there, and those queries have been completed. Now we can make our DNS change, and then we'll do another dig, point to the same file, and we'll call this after DNS change. Okay, now we have those 2 records in there, and now we can outputs of those 2 dig results in those 2 different files. Now we can do a diff before change, DNS change, and after DNS change. Okay, and we had 4 records in our file, our dig txt. So we had f5.com and LinkedIn. Notice those domains did not change the lookup, but google.com gave us a different answer the next time, and Gmail gave us a different answer the next time. And notice the TTL is we specified to ignore that information in the answer section. So really you can get pretty creative with what information you want to see from the dig result, and then point it to have it run using the -f function before and make your DNS change, and then do it after, and you can use the local diff config on the big IP platform to see the exact differences there. Okay, so let's look at our last DNS troubleshooting tool for this video, NSLookup. So NSLookup has 2 modes. It's a non-interactive mode, which you can run all the flags and options in one line, and then there's an interactive mode where you type in NSLookup, hit enter, and then you can start specifying different options and kind of keep those requests for multiple queries going forward. So the interactive mode will set all of the configuration settings for that specific session. So as soon as you log out or get out of the interactive mode prompt, then your set settings for that session will go away. So it's nice to be able to set a bunch of settings if you're going to use the same in interactive mode, and then just hit a bunch of servers with those same exact settings. Nice way to do it. Okay, so the non-interactive mode, we look at just a normal. This is a normal a query for gmail.com, and the DNS server that we're pointing to is 8888. Okay, and specifies A records by default. Okay? And if we want to specify a different different DNS record type other than A, we can use NSLookup type, and in this case we're specifying an MX record that we want to query for to gmail.com. Okay, so moving on to interactive mode, we type NSLookup in our client, hit enter. We can use the help feature to display a lot of useful information, but we can set the server that we want to point to if it's not the same as our existing DNS server. We could set a specific one for just that query session. We could specify the type. In this case, equals any, and then we can specify our query. So we can just type in the domain. In this case, gmail.com is our fully qualified domain name, and with NSLookup, it actually, if you don't specify the dot, it's going to recognize that as appending, or the ability to append the local system's domain or suffix to that. So to be more specific and to not have additional information, we want to append that final dot to our domains. We can set recursion just like dig, or not to recurse with our specific flag functions. The set all is used to display all the current functions, and it just applies to that current NSLookup session. We can set the debug to get debug on the answers we receive, so more verbose information, and this is probably one of the D2, set D2, getting debug and requests and answers. It's a complete dump, and that's really one of the major benefits that I see in using NSLookup over dig, is that it'll display debug requests, not just information on the answers we receive. So the dig has a trace utility that runs through the answers you receive, but it doesn't send, or it doesn't output what you actually sent from a client perspective. Other than that, dig is really more, it has a little more options and features you can use, but this is a specific option you could use for NSLOOKUP. So which one would you use? I mean, sometimes it's the system that you jump on, and if it doesn't have dig, then you use NSLOOKUP. If it has dig and it doesn't have NSLOOKUP capabilities, you use dig. So it's just really what you have to work with at the time. I think you can find a pretty good use case for both, as they pretty much support the same amount of features as each other. Okay, and last is the set search list. By default, if you do a set all, you'll see that the domain of the local system is appended. You could specify a search list to identify a different local suffix or domain. Okay, let's play around with NSLOOKUP at the command line and look at a few examples. So for non-interactive mode, this is where we specify the full query string in one line. So we can do a query to gmail.com pointing to the Google DNS server to get that address. Okay, and to specify a type or a specific type of DNS record, we could do -type equals mx, for instance, and do gmail.com, and you can see it gives back the mx records. Okay, so for NSLOOKUP, the non-interactive mode, which is this one right here, there's not a lot of help section output in the non-interactive mode, but we can go to NSLOOKUP and type in help. This is interactive mode. Now we are able to set our options, and this is what's different about interactive mode versus non-interactive mode. We can set the options, and they remain persistent until we exit the current session. So you notice this greater than sign here. This means we're in the current NSLOOKUP session. So if I set a certain variable, like I'll set the timeout to 3. Okay. So the timeouts right now is 3 in the default configuration output. And then I'll specify or set the search list to google.com. Okay, and I do a set all, and you can see the timeout is 3 and the search list is google.com, the domain is google.com. Okay, so if I were to exit this session and NSLOOKUP, go back into interactive mode and do a set all, you can see that my systems are back to the default. So timeout 2 is the default, and then my domain is different. Okay, so we can set the specific server that we want to point to globally. So if we wanted to point to level 3's DNS, we will stick with Google DNS for our example. And we'll set the type to any for any DNS records from the query type. So if we type in gmail.com dot, for instance, this is the fully qualified domain name. It's important to include this dot, or else it will append the suffix from the search list. So it'll actually maybe not give you what you want the first part of the query. So we'll enter the dot, and then we can get all the records. So we could see the MX record, name server record, TXT records for that was gmail.com dot. Okay, well, we could do linkedin.com dot, and you can see here that linkedin.com currently doesn't support the any record type obviously for security purposes, allowing users not to kind of walk or get all the records for a particular domain. But the set type will remain persistent. So when we did MX, we could specify, all the MX for gmail.com, for f5.com dot, and we don't have to type in the new query, which is a nice feature for interactive mode. Okay, and we can do the set debug, and we'll go ahead, we'll set the type to any, and go to google.com. Okay, so with there's like normally 3 sections here. So the bottom is going to be the non-authoritative answer, and we should see the get answer section or got answer section, and as well as so we set the debug. The set debug includes just the answer debug output, so that the additional headers, header information, and the answer section output is a little more verbose than a normal output. So if we type in help, now we're going to specify the D2, which is printing an exhaustive debugging information, which is basically saying it's going to get the debug requests and answers. So instead of just the answers, it's going to also get more information from the send request. So we'll type in set D2 and go to google.com. Alright, so we see the non-authoritative answer section, and now we get the answer like we did before, but now in this case we're using the D2 option. In the interactive mode, we're able to see additional header information with what we send, which is kind of a nice feature for NS lookup. So we send the query wanting recursion, one question, and the question type. It's a nice feature to have when you want to verify exactly what's being sent from a client instead of just the response. Dig has a similar output, maybe showing a little bit different flags, but all in all, very helpful tools, both Dig and NSLookup, for troubleshooting DNS. Okay, so I hope you enjoyed this video on DNS troubleshooting tools as we took a deep dive into OpenSSL, TCP dump, a little bit about SSL dump, and Dig and NSLookup in Objective 301. So up next, we're going to take a look at Objective 302 and talking about diagnosing big IP DNS issues. I will see you in the next one.